The next concept involves reflecting figures about horizontal and vertical lines that are not the axes of the coordinate plane. Let's start with an example. Reflect the figure across the line x equals -2 and write down the coordinates of the points found in both the pre-image and image. Let's actually start by writing down the points in the pre-image. So we have point A is at -1, 4. Point B is at 1, 6. Point C is at 3, 5. Point D is at 2, -1. And point E is at -1, 2. Now let's work on reflecting these points about the line x equals -2. Okay, so x equals -2 is going to be this line right here. So here's our line of reflection. So we're going to use the same strategies that we've been using this whole time, counting the number of spaces required to get from each point to the line of reflection, and then counting that same number on the other side. So for point A, we have to go 1, so we have to go one more unit here to get to A prime. And then for B, we have to go 1, 2, 3, so we'll go 1, 2, 3 over here. So here's where B prime is going to be. Now for C, we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. C prime. D prime, 1, 2, 3, 4. 1, 2, 3, 4. And E prime is just one space on the other side, right below point A. All right, so now if we connect these to form our shape, our pentagon, it'll look something like this. And now let's also write down the coordinates of our image points. So A prime is at -3, 4. Point B prime is at -5, 6. C prime is at -7, 5. D prime is at -6, -1. And E prime is at -3, 2. And here's the solutions, and here's the image after the pentagon is reflected across the line x equals -2. It does match what we found when we did the problem ourselves. And these are the new coordinates. A went from -1, 4 to -3, 4. B went from 1, 6 to -5, 6. C went from 3, 5 to -7, 5. Point D went from 2, -1 to -6, -1. And point E went from -1, 2 to -3, 2. Now let's try to reflect this figure across the line x equals 3. So if we reflect it across the line x equals 3, that line will be right here. So right here is where x equals 3, that line is. And one thing that I noticed right away is, well, point C is right on that line. So C prime is going to be in that same location. It's not going to move. Now let's find out where all the other points are going to be. So A, we have to go 1, 2, 3, 4 to get to the line of reflection. So we have to do that again. 1, 2, 3, 4. So here's where A prime will be in this case. B, we have to go 2 to get to the line of reflection, so 2 more. We'll put B prime up here. We already did C prime. D prime has 1 unit, so we have to go 1 unit further. And then for E, we have to go 1, 2, 3, 4, 1, 2, 3, 4. So E prime is going to be right here. And then if we connect them, we will get this pentagon. And then let's also look at the coordinates of our pre-image and image. So point A is at -1, 4, and A prime is at 7, 4. Point B is at 1, 6, and point B prime is at 5, 6. Point C is at 3, 5. C prime is also at 3, 5 because it lied on the line of reflection. Point D is at 2, -1, and point D prime is at 4, -1, and then point E is at -1, 2, and point E prime is at 7, 2. Okay, and we see the solution to this problem. So here's the line of reflection, x equals 3. We noted that C and C prime are exactly the same. And then A and A prime, B and B prime, D and D prime, E and E prime do share the coordinates that we had found. The pre-image and image coordinates of the last two examples are provided below. When we reflected pentagon ABCDE across the line x equals -2, point A went from -1, 4 to -3, 4. B went from 1, 6 to -5, 6. C went from 3, 5 to -7, 5. Point D went from 2, -1 to -6, -1. And point E went from -1, 2 to -3, -2. When the line of reflection was x equals 3, point A went from -1, 4 to A prime, which is 7, 4 in this case. B went from 1, 6 again, but to 5, 6. C was at 3, 5, and it remained at 3, 5. Point D was at 2, -1, and went to 4, -1. And point E was at -1, 2, and went to 7, 2. What generalizations can be made about reflecting points across the vertical lines? How do the x and y coordinates change or remain the same? Take a moment to pause this video and think about it, and when you're done, unpause it. Well, the pre-image and image points all have the same corresponding y coordinate. These things never changed. Let's look at the other pair to make sure. Yeah, 6 to 6, 5 to 5, -1, -1, 2, 2. So the y coordinate of our original point does not change when we reflect it across a vertical line. the x-coordinate does change. Let's try to see if we can figure out how these x-coordinates that we're given and the line of reflection might be able to produce our image points. So I have a -1 and a -2. I got to do something with -2 and -1 to get me to -3. So let's write that down. We have something going on with a -2, and then we're doing something with -1, and we're going to end up getting -3 as a result. And the same type of thing is going to happen here. We're going to do something with -2, and then we're going to have something with 1 involved to give us -5. Well, if I actually look at this one's a little bit easier. If I did 2 times -2, I'd be at -4, and then if I subtract 1 from -4, I do get -5. So let's see if 2 times this and subtract this value, does it give us -3? 2 times -2 is -4. -4 minus -1, or it turns into +1, does give us -3. Okay, does 2 times -2 minus 3 give us -7? Oh, it does. So I'm doubling the line of reflection and then subtracting the original x-coordinate. And the y-coordinate is remaining the same again. So if we were to say that k represents our line of reflection, and we double the line of reflection and then subtract the corresponding x-coordinate, we do end up getting the new x-coordinate, and we'll again verify it here. So 2 times -2 minus the x-coordinate here is 2. -4 minus 2 does indeed give me -6. 2 times -2, it's the line of reflection, minus -1, which turns into +1, does indeed give us -3. If we do that same formula process with these, this time our k value is 3. 2 times 3 minus -1. Well, minus -1 becomes a +1. 2 times 3 is 6, plus 1 does give us 7. 2 times 3 minus 1, 6 minus 1 does give us 5. 2 times 3 minus 3, 6 minus 3 is 3. So it does indeed work. The line of reflection value is 3 minus 2. 6 minus 2 does give us 4. 2 times 3 minus -1. This becomes a plus. 6 plus 1 does give us 7. So yes, this 2k minus x comma y is indeed the formula for finding the new x-coordinates after reflecting about a vertical line. So again, it's x comma y goes to 2k minus x comma y, where k represents that line of reflection. Now that we've gone through reflecting about vertical lines, let's talk about reflecting about horizontal lines that are not the x-axis. Reflect the figure across the line y equals -2. Well, y equals -2 is going to be this line right here. So from A to this line, it'll be 1, 2, 3, 4, 5, 6. So we have to go 6 again. 1, 2, 3, 4, 5, 6. So here's where A prime will be. Our original point A is at -1, 4, and A prime is -1, -8. Now let's look at B. Point B is at 1, 6, and point B prime, let's count to get there, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Here's where B prime is going to be, and that is at 1, -10. Point C is at 3, 5. And let's count to figure out what the coordinates of C prime will be. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Here's where C prime is going to be, which is at 3, -9. Point D is at 2, -1, and D prime is going to be right here because it's only 1 away from the line of reflection, so we got to go down 1 more. And D prime's coordinates are 2, -3. And then for point E, it is at -1, 2. And E prime will be 1, 2, 3, 4 down to get to the line of reflection. So we got to go down 4 more. 1, 2, 3, 4. So E prime is right here at -1, -6. And if we connect our new vertices, we will get the image for the new pentagon A prime, B prime, C prime, D prime, E prime. And here's the solution for reflecting our pentagon A, B, C, D, E across the line y equals -2 to get pentagon A prime, B prime, C prime, D prime, E prime. And the coordinates that we calculated are justified in the solution shown here. A went from -1, 4 to A prime, -1, -8. B, 1, 6 went to B prime, 1, -10. C at 3, 5 went to C prime at 3, -9. D at 2, -1 went to D prime, 2, -3. And E at point -1, 2 went to E prime, -1, -6. Let's try another example where we're reflecting about horizontal lines. Reflect the figure across the line y equals 1. Well, y equals 1 is going to be right here. And then we're going to write down the coordinates of the points found in both the pre-image and image. So we can start by writing down our original pre-image points. Point A is -1, 4. B is 1, 6. C is 3, 5. D is 2, -1. And E is at -1, 2. Okay. Now let's find our image points. Let's start off with point A. When reflecting, it's easy to count number of spaces from the pre-image point to the line of reflection and counting the same number of spaces on the other side. So for A, we have to go 1, 2, 3 units down. So let's go 3 more. 1, 2, 3. So this time A prime is going to be here at -1, -2. All right, so from B to the line of reflection, we have to go down 1, 2, 3, 4, 5. So I have to go down 5 more. 1, 2, 3, 4, 5. So B prime is at point 1, negative 4. Okay, point C, we have to go down 1, 2, 3, 4. So we have to go down 4 more. 1, 2, 3, 4. And the coordinates of C prime are 3, negative 3. And for D, we actually have to go up 2 to get to the line of reflection. So we have to go up 2 again. So for D prime, those coordinates are 2, 3. And then for E, we have to go down 1 to get to the line of reflection. So we have to go down 1 more. So E prime is here at negative 1, 0. And if we connect our points, we will get our image pentagon A prime, B prime, C prime, D prime, E prime. All right, so here is the solution to this example problem. It does match the diagram that we drew and the coordinates that we found. A went from negative 1, 4 to A prime, negative 1, negative 2. B went from 1, 6 to B prime, 1, negative 4. C went from 3, 5 to C prime, 3, negative 3. D went from 2, negative 1 to 2, 3. E went from negative 1, 2 to E prime, negative 1, 0. The pre-image and image coordinates of the last two examples are provided below. When the line of reflection was y equals negative 2, A went from negative 1, 4 to negative 1, negative 8. B went from 1, 6 to 1, negative 10. C went from 3, 5 to 3, negative 9. D went from 2, negative 1 to 2, negative 3. And E went from negative 1, 2 to negative 1, negative 6. And when the line of reflection was y equals 1, A went from negative 1, 4 to A prime, negative 1, negative 2. B went from 1, 6 to B prime, 1, negative 4. C went from 3, 5 to C prime, 3, negative 3. D went from 2, negative 1 to D prime, 2, 3. E went from negative 1, 2 to E prime, negative 1, 0. What generalizations can be made about reflecting points across horizontal lines? Take a moment to think about it by pausing the video, and when you're done thinking about it, unpause it. The pre-image and image coordinates of the last two examples are provided below. When the line of reflection was y equals negative 2, point A went from negative 1, 4 to A prime, negative 1, negative 8. B, 1, 6 went to B prime, 1, negative 10. C went from 3, 5 to C prime, C 3, negative 9. Point D went from 2, negative 1 to D prime, 2, negative 3. Point E went from negative 1, 2 to E prime, negative 1, negative 6. When the line of reflection was y equals 1, the point A at negative 1, 4 became negative 1, negative 2. Point B at 1, 6 became B prime at 1, negative 4. Point C at 3, 5 became C prime at 3, negative 3. Point D at 2, negative 1 became point D prime, 2, 3. Point E, negative 1, 2 became E prime, negative 1, 0, after being reflected across the line y equals 1. What generalizations can be made about reflecting points across these horizontal lines? Well, we can clearly see by looking at these that the x-coordinates are not changing. They are remaining the same. So let's start our formula with xy goes to x, comma, and leave a blank space to figure out what's happening with the y-coordinates. So what do we have to do with this line of reflection at negative 2 and 4 to get to negative 8. So something with negative 2 and 4 will have to give me negative 8. Something happening with negative 2 and 6 to get to negative 10. Something is happening with negative 2 and 5 to get negative 9. Well, if we do 2 times negative 2, we get negative 4, and then if we subtract 4, we get negative 8. Let's see if that holds true every time. 2 times negative 2 is negative 4, minus 6 is negative 10. 2 times negative 2 is negative 4, minus 5 does give us negative 9. Okay, so it looks like we're taking 2 times the line of reflection, let's call that k, and then we're subtracting the original y coordinate to get our next point. So does negative 3 result from taking 2, multiplying it by negative 2, and then subtracting negative 1? Yes, it does. Negative 4 plus 1 gives us negative 3. 2 times negative 2 minus 2 does indeed give us negative 6. If we do that same analysis over here, is 2 times 1, our line of reflection, minus our original y coordinate of 4, does that give me negative 2? Yes, it does. 2 times 1 minus 6 does indeed give me negative 4. 2 times 1 minus 5 does give me negative 3. 2 times 1 minus negative 1, this will become plus, does give me 3. 2 times 1 minus 2 gives me 0. So yes, we have just proven that when reflecting about the line y equals k, where k is a constant, the new y coordinate is found by doubling the line of reflection and subtracting the original y coordinate. The x coordinate remains the same. In other words, xy goes to x comma 2k minus y.